In the previous lesson, you have been introduced to acids and base. For this lesson, we are going to measure the strength of acids and bases. Well, the most commonly used way to measure the strength of an acid or alkali is by using the pH scale. Well, the pH scale is actually a measure of how acidic or alkaline a solution is. What is pH? pH is actually the abbreviation for power of hydrogen. Yeah, so it stands for power of the hydrogen. And this formula is equivalent to negative log 10 to the concentration of hydrogen ion. Yep, so this is the meaning of pH. You do not need to remember this formula, don't worry. And the pH scale will have values from 0 to 14. I'm sure you have seen this scale before, right? And in the middle is 7 and the end is 14. A solution with a pH less than 7, they are considered as acidic, and a solution with a pH greater than 7 is known to be alkaline. How about the solution with a pH of 7? These we study them as neutral, right? So to make the long story short, whatever below 7 is acidic and whatever above 7 is alkaline. The lower the pH value, the more acidic the solution is, and therefore it has more hydrogen ion. That means if I talk about acid from 0 to 7, the lower the pH value means towards 0, these will be more acidic. More acidic means they have more hydrogen ion. And what can you see from the pH value? Less pH value. An example will be hydrochloric acid, nitric acid, and so on. How about lemon juice? Lemon juice is not as corrosive as hydrochloric acid, right? So probably lemon juice could have a pH of 3 or 2. And how about milk? Milk is slightly acidic, actually, just a little bit of acidic. Probably it will be pH number 6. Alright, the higher the number, the more alkaline the solution is and the more hydroxide ions it contains. So when the scale goes towards pH 14, then it shows us more alkaline. More alkaline means more OH minus ion, and what we can see from the value of pH, it has a higher pH value. An example of this will be dilute sodium hydroxide. How about detergent? Detergent is also alkaline, but it's less corrosive, right? Less alkaline compared to sodium hydroxide. So it probably have a pH of 11. Yep. So let's conclude this. pH 7 is neutral. Whatever below neutral is acidic, and whatever above neutral is alkaline. And let's go down first. The lower the pH value, the more acidic the solution is, and therefore it has more hydrogen ion. So when it goes towards 7, it becomes less acidic. Less acidic means it contains less hydrogen ion. But what can I say about the pH value? It will be having a higher pH value compared to the lower one, right? So for the 0, we consider this as strong acid, and towards 7, we consider this as weaker acid. And after 7, we talk about alkali. So the one that goes towards pH 14 is strong alkali. It has high concentration of OH minus ion, and it has a higher pH value compared to an alkali which is nearer to 7. Yep, so nearer to 7 is known as a weak alkali. If it's a weak alkali, therefore it has lesser OH minus ion, and when we compare the pH value with the strong one, it has a lesser pH value compared to a strong alkali. And how can we measure the pH of a solution? We only know the pH, right? More than 7, less than 7, or 7. But how do we measure it? There are few ways to measure it. The one that we usually use in the lab will be known as an indicator. And indicators are substances that have different colors in acidic and alkaline solution. And probably the most commonly used indicator in the lab is the litmus paper. Can you remember what's the color of litmus paper when it's acidic? It's red, right? How about when it's neutral? It is violet in color. And if I put it into an alkaline solution, the red litmus paper turns blue. Alright, so this is one of the most commonly used indicator in the lab. And when we go into Form 4 and 5, we also use other indicators. And another one that you will be using in your lab is known as the phenolphthalein indicator. Phenolphthalein indicator. When it's acidic, it shows us no color. When it's neutral, it also has no color. And when it's alkaline, it shows us pink color. Alright, so this is phenolphthalein indicator. And let's try one more. Another one that we use is known as methyl orange. And methyl orange is an indicator that shows pink when put into an acidic solution, orange when it's neutral, so it's easy to remember, orange when it's neutral, and alkaline, it will be yellow in color. Alright, now besides using indicator like litmus, phenolphthalein, and methyl orange, we also can use a pH meter. pH meter is actually an electrical meter used to measure the pH of the solution. Okay, and before we end the lesson, let's just look at the strong acid, strong alkaline, weak acid, and weak alkaline again. Now, the strength of an acid depends on the proportion of its molecules that ionize to produce hydrogen ions, which is H plus. So we are going to call it degree of dissociation. Yeah. When we mention strong acid, strong alkaline, or weak acid, weak alkaline, we have to mention the degree of dissociation. The acid that has a higher degree of dissociation will have a lower pH, because when it has a higher degree of dissociation, it can actually release a lot of hydrogen ion, right? And a strong acid is considered as an acid that dissociates completely in water. So when we talk about strong acid, it 100% dissociates in water. And when it dissociates 100% in water, that means it can release all the hydrogen ions. This means that all the acid molecules will ionize in water, and a good example will be hydrochloric acid. Yeah, a solution of hydrochloric acid contains only hydrogen and chloride ions. So when it dissociates in water, we only get H plus and Cl minus. There is no hydrogen that is hidden, right? So this is considered high degree of dissociation. How about a weak acid? Well, weak acid, they do not dissociate 100%. Only a small percentage is dissociated. For example, ethanoic acid, or what we commonly known as vinegar, is considered as a weak acid. Yeah, vinegar is considered as weak acid, and when I put it in water, only 0.4% of the molecules ionize to produce hydrogen ions. The remaining 99.6% of the molecules remain unchanged. So they cannot release all the hydrogen ions, right? Therefore, they are known as weak acid. So weak acid has a degree of dissociation which is lesser than 100. As compared to alkali, the strength of the alkali depends on the proportion of its molecules that ionize to produce hydroxide ions. Yep, so be careful. For acid, it's actually the dissociation to form hydrogen ion. But when we talk about alkali, we have to talk about the hydroxide ions, and this is known as the degree of dissociation for hydroxide ions. So the same thing as acid. If we have a strong alkali means it 100% dissociates in water. And if it dissociates in water 100%, it releases a lot of hydroxide ion, right? A good example would be sodium hydroxide. So in the presence of water, the Na plus and the OH minus will be completely separated from each other. And as you can see, it will create a high percentage of OH minus ion. So we call this strong alkali. On the other hand, a weak alkali, that means it only dissociates in small percentage, right? They only dissociate to a small percentage in water. Only a few molecules ionize to produce hydroxide ions. So as a result, the concentration of hydroxide ions in the solution is low. Alright. So please remember, when we talk about strong acid means it dissociates 100% in water, therefore creating a high concentration of hydrogen ions and has a lower pH value. A weak acid, the other way around, right? It partially dissociates and it has a low concentration of hydrogen ion and it has a higher pH value. Now for alkali, strong alkali dissociates completely in water to create a high concentration of hydroxide ion and it has a high pH value. A weak acid partially dissociates in water, therefore it has only a low concentration of hydrogen ion and it has a lower pH value compared to the strong alkali.